Okay, we're just going to go through something on the NumFOCUS website that some people know about, but it's also a good introduction to all of the NumFOCUS projects. So you're on numfocus.org, projects. There's sponsored and affiliated. If we have time, we'll look at affiliated. We're going to go to sponsored projects. What's the difference between sponsored and affiliated project at NumFOCUS, you ask? A sponsored project are projects that NumFOCUS has signed a fiscal sponsorship agreement, which is a legal agreement, and NumFOCUS is serving as a legal entity for that project. We sign for them on legal documents. We take on all liability, so it is the individual developers do not have liability, again, handling their legal administration of all their finances and many other things. But what this is a great tool that has all our projects on it, and you can go through and you can look at language or features, and we'll just pull up if we want to see what's Python and, well, let's see, we'll pick another one, Python and JavaScript. And you look, and it will pull those up. So you can do that with any of the projects or languages. It's kind of a handy tool because many people ask, what language can this project work with? So that is one thing. The other one is features. If you wanted to see all the modeling tools, then it shows all the modeling tools, and so you have those pulled up, and you're wondering which we get. I've heard this question asked 3 times today, what this sticker is, right here. So that's Cantera. So you want to learn more about Cantera, you can click on Cantera, and we find out that it's an open source software suite that helps solve problems involving thermodynamics, chemical reaction rates, and fluid transport processes. And you could go down further, a description, technical details, as well as applications for the project. That's just drilling down a little bit deeper. Applications lets you know that the largest user base of Cantera is in the combustion field, but it can be used in other atmospheric and astronomical chemistry. So go back to projects. So that is features. We'll uncheck modeling. And you can also do run a search based on industry, whether it's business, higher education, it's used in academia, or government. We'll click on government really quick. See what comes up. So it's showing that these 12 tools are used in government. I think that's somewhat incorrect because I know many other ones that are also a couple other ones that I know for a fact are used that aren't on here, maybe just 1 or 2. But that's most of them. And again, I'm trying to think of another, I know another project that someone, while I was at the table with the stickers, asked what it was. That's Interact. So again, we find out that, now clicked on the Interact page. Let me go back here. It's a standalone desktop application for developing computational notebooks. And again, it's you can look at its applications that it's being used extensively at Netflix and also being used by Plotly. So hopefully you find that helpful. The other thing that's kind of nifty here is that there's a button to contribute code. So for all our projects have a page, you click on that, it will tell you about contributing code to that project. It doesn't go into doesn't, it's not a contributor workshop, but it does tell you information on how to contribute code. And that's on there for each of our projects, as well as a easy link to the website and how to donate specifically to that project. Because donations can be made to NumFOCUS for all the projects, so those donations, all the projects, or you can donate to a project specifically. So this will take you to the specific project page. So, and again, just super quickly, I won't go into any details, but the affiliated project, if you want information on our affiliated projects, these projects are able to apply for NumFOCUS small development grants, and they're included in many of our announcements and just informational resources that we send out to projects. You can take a look at all the affiliated projects and find out all about them on this page. So, thanks.
Hi everyone, so I just want to talk briefly about model explainability, and in particular the library we've developed at Selden, where I work at. So the library is called Alibi, and it enables you to explain black box model predictions. So model explainability is a huge topic, so I could talk for hours. I don't have hours, so let's jump into some examples. So for example, I've a data set, income classification. This is a standard data set. It's got about 13 features, age, working class of the individuals, and it's a binary classification problem, whether the individual makes more than or less than 50K a year. So I split the data. I've trained an off-the-shelf classifier. By the way, all these examples are available as documentation on our website, so don't worry if you can't follow all of it. But I have a trained classifier. It has some performance, but now I want to explain specific predictions. So I'm going to use an anchor explainer, which will find the most important features for that particular instance from the point of view of the model to make a positive or negative prediction. So I initialize the explainer, fit it on the training data. I'll try and get one instance. I've got an instance, an individual for whom the model predicts that they're a low earner. Okay, but why? So then we can run the explainer and we'll see, okay, the model thinks that because the marital status is never married, it will always predict low income because of that. And you see there's some metadata there. It gives you guarantees how where this explanation applies, so 92% precision. So this explanation will be valid roughly 92% of the time. So if you look into interpretability, LIME is a technique that was developed maybe 4 years ago, and anchors are from the same authors, and it's kind of like an improvement on LIME, more robust, gives you more guarantees. It's not limited to tabular data sets. You can do it in images. So let's say there's a fashion MNIST data set, 10 categories. I've trained a CNN offline, do some predictions. I've segmented the image into superpixels so that computation of anchors is quicker and also more interpretable. And then, again, anchors are a completely black box method, so all you need is a predict function. This could be anything. It can be a naked API running in production, so if you want, you can wrap up your explainer with a Flask server and run as a microservice in production, which we have examples of in Selden Core. Anyway, back to the explanations. Let's see. That's a pullover with 99% confidence by the model. What's the explanation? Let's do the anchor. Okay, that's the anchor. So as long as there's like this right sleeve, I guess, or left sleeve, the model thinks it's always a pullover and nothing else. So it's a simple data set. So that's where you get a simple anchor. Runs on more complex data sets. ImageNet, it's a Persian cat. Why is it a Persian cat? Well, because of this. Okay, another interesting technique is counterfactuals, which ask the opposite question: what do I need to change for my model, for my instance, to get the opposite prediction of the model? So there's an example with the Boston housing data set. Again, a classification problem: is any given house more or less valuable than the median value in the neighborhood? And we've trained some model. And now we can create a counterfactual instance of a house, given that a house was classified as low value. What do we need to change to classify it as high value? And if I run this example, it actually says, okay, actually I need to sort of, let's see, LSTAT, decrease the percentage of the lower status of population in the area to get a positive prediction. So you can't, this is not actionable, right? So you can't change that. But with counterfactuals, you can restrict your attention to which features are actionable. So you can find counterfactual instances and then act on them. So that could be useful. Yeah, so we have a few other techniques. Oh yeah, well, counterfactuals also work on images. This is a 7. You want to see what you want to change to get not a 7, and you get 4. No, that was a different example. Anyway, that's my time. Thank you.
Cool, good to see everyone here. So I'm just going to quickly go through these slides. Quite new to Python, so let me know if you guys have any feedback in terms of making code better and stuff. But essentially the idea here is that the UK police forces, they produce crime data and they put it up so that people can download it, do whatever they want with it. So I'm basically going to go through that and essentially how I've visualized it using matplotlib and plotly. So we can go through that as well. Cool. So what's the motivation? Well, so it was me and my partner who actually did this very quick thing, but we're kind of looking to rent/buy a house. So, we want to find places which have slightly lower crime, or we want to find streets specifically which have lower crime or higher crime, and, kind of make a decision from there. So there are crime maps available, but the problem is that most of the times they're very hard to work with. So it's either they just give you data for 1 month or for one region, and then you have to kind of click through and go through each month to find out, the data. So the idea here is to try and get all of that data and be able to visualize that at the same time. The data is really good. It's really good that they've put it there. I'm sure there's much more interesting things that people can do, but this is just the start. And yeah, so that's the idea. So I'm just going to go through this Jupyter notebook that we've made, and it's on GitHub. GitHub name is joy-rosie, and it's UK crime police data. Yeah, you can find the notebook there. So we do all the imports. We use pandas, GeoPandas, matplotlib, and plotly. Those are the 4 main things that we're using. And I'm using this thing called Mapbox. So Mapbox is it's basically an API that is actually embedded within Plotly, so you can kind of use their street-level maps and other maps to try and basically visualize these things. So user parameters, wherever you store the data, which I have a script for as well for downloading the data. It's just not in here. What's the region, what kind of data type it is, and what are the start and the end dates. So this is what the raw data looks like. There's some crime ID, there's month, reported by, so this is the police service, longitude, latitude of the street, location, some codes, and the crime type. So then what we do is we clean the data, we make it look a bit nicer. We only want certain things, at least in this specific case. We want the longitude, latitude, and the crime type, and the date. So then we use GeoPandas, which is awesome. If anyone's, if you guys haven't used it, do check it out. So it's basically you can work with geometries and do cool things like spatial joins. So if you have a point and you can do a join on a polygon, and then you can put them together. So it's an equivalent of doing left joins and stuff from SQL. So I'm just getting what's called the CRS, so that's a coordinate reference system. So essentially here what I'm trying to do is I'm just trying to get out the data for London, not the whole of UK, because that's what I'm interested in specifically. So what I can do is, as long as I know the longitude, latitude boundaries of London, I can spatial join all of my data onto there to only get the London data. So imagine you have the whole of the UK data, but you only want the London data. How do you do it? Well, you can use GeoPandas to do this join and just get out what you want in the end. This is just, there's some unnecessary stuff dealing with coordinate systems, but it's done here. And then, so first thing that we do, visualize in matplotlib. Very simple. We just have the pandas object, or the geopandas object in this case. We just do dot plot, blah 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 blah, and you get out the plot. So you can see the blue is just the London area, and then the red is each crime in London. And this is for 5 years. So it'd be nice to kind of live here, but that's actually a lake or something. And then what we do is we then use Plotly. So I aggregate all the data by street, by the data type, by the crime type. So that's like antisocial behavior, shoplifting, robbery, so on and so forth. And this is what it looks like. So I was really impressed with the Plotly and the Mapbox stuff. So this is quite interactive. So I've tried to make it somewhat like a heat map, and you can zoom in. So I think we are here right now. So let's just pull this over. So we're in this area, somewhere around here, and we can have a look. Okay, well, there's been about 200 crimes in the past 5 years, and but it doesn't seem that a lot of them are antisocial behavior. So it's just hopefully children walking around doing naughty things. But that's it. Thank you.
Hello, everyone. So I'm Elisa, and I'm here with Cambridge Spark. The screen up here may have given you a clue as to what I'm here to speak about. So how is everyone enjoying the PyData conference so far? Fantastic. That's what I like to hear, because I'm here to talk about PyData Cambridge, which, of course, yeah, you're all excited about already. Fantastic. So I just wanted to take a couple minutes of your time to let you know that we are organizing PyData Cambridge on the 15th to the 17th of November this year. We do have a stand just here by the T-shirts, so if you'd like some more information about that event, just come across and talk to us, or just come and grab a little postcard just to remind yourself when it's happening, so you don't forget to buy your tickets, or, sponsor the event, or, have a talk, whatever it is that you're interested in. I'm going to keep it short and sweet. You know where to find me, so enjoy the rest of the conference. Thank you.
Yeah, I don't come with the slides this time. I come with my Twitter handler that can be very useful after the bad jokes when you want to block me. So I'm going to show you something I've been working on recently. It's a new pandas feature. Let me just show you first. This is pandas, as a disclaimer. It's the pandas of the future. 0.25. It's still not released. It's in release candidate. So let me just open a, oops. It's actually easier to write when not so many people is looking at you. But yeah, I got a data set with all the PyData meetups. Okay, actually I got more columns, but I just cared about these two. So I think you probably all know about this. I'm going to check just like past events dot plot. No, sorry, I'm going to just plot just the largest ones. Let's see how this looks like. Yeah, cool. The largest PyData, the PyData that organizes more events is PyData London, together with PyData Berlin. I think some organizers did a lot of work. Then we have things like PyData New York organizes as many as a small island in Spain. I don't know where is James, but maybe he wants to tell us how long are siestas. Oh, what that was. How long are siestas in New York? I'm going to go to member counts. Member count. Okay, we got by far the largest is PyData London. I'm going to do another plot. Oops, sorry. I'm actually not great with time, but let's see. So I want to plot again the member count. Is it big enough? Are you seeing anything? Okay. And I'm going to plot also the past events, so I'm going to plot both things. I think that should be good enough. Okay, and it looks like in this scatter plot we have something that looks like an outlier. And of course, most of us here are, or at least many of us are data scientists. We know that we want to get rid of outliers, but we don't know which is the PyData we want to get rid of. So I would say that in general, what you would do is probably check this axis, say, okay, do a filter and isolate this stuff. What is new in the new version of pandas is, let me go somewhere here. It's like pandas.options.plotting.backend. Oops, I'm missing a no here. Backend, I'm going to say this is hvplot. Okay, and what I'm getting now is interactive plots. Okay, now we can see exactly how many members has PyData London. Well, that was yesterday when I generated this data frame. Now we can also detect this outlier. Yeah, this is the PyData we need to get rid of. Sorry, Marco and Ian and the rest of organizers. And I don't know, I thought you wouldn't be impressed, so I implemented my own plotting backend. Now pandas will support any plotting, will support Altair or Plotly or any backend that is implemented. It would be third-party libraries. I implemented one that it was so awesome that I had to rename it after the first version. Okay, what it does is it plots with emojis. Okay. It's actually a bit sad, but still a bit too realistic because, as you see, all the faces are men. I didn't like that, so what I did was you have an option that you can implement and say, okay, they are all women now, women. It's kind of cool. It's not really diverse. I thought it was. I can even be cooler, so everyone can be a panda. But yeah, in terms of diversity, this is not being great, and because I don't have actually time, let me just go quickly to the future and see what this library is able to tell about all these PyDatas in the future. Okay, it's making it as diverse as we want the community. So because I just have 5 seconds left to show my skater. Okay, I didn't have a skater for that. Thank you.
So yeah, I want to show you this thing. So this, now in this video, it's like showing it's showing an error message, because yeah, why not? This thing is called Pew Pew, which I got as a gift. If you can see, it's a gift from EuroPython, and it's super cool because I know that most of us are data scientists, so we use Python to work with data, but not a lot of us was able to use Python for something that is more fun. Yeah, so I'm looking at like all these crazy things that people created. Like for example, this one is the game 2048. Who had played that game on your phone before? Yes, so somebody programmed it on this thing. So, but this is just an image, so I can't really show you. But this one I can show you the thing. Like somebody programmed a Flappy Bird. With this. Also, somebody programmed a clock. This one is gonna take more than 5 minutes, I think, because yeah, this is gonna move. But it's analog clock, but you have to tilt your head. Yeah. So I would like to show you my creation, because of course my creation is, now you can see me. Hi, you see me? Okay. So yeah, this thing. So my creation is not as creative as those. It's just a heart, which could go small and big and go slowly or fast. And it could also stop and start blinking again. You can be like, yeah, change it. So yeah, this thing is, okay, I feel weird looking at myself, so let me close it. So yeah, so basically this thing is run on a circuit Python, so it's like a lightweight version of Python. And also, if you are lucky as me, you have been to EuroPython, you get one of these, and then there's some code inside that is provide an API that you could write a program very easily. So that's why within an hour or so I can already write this hot thingy. So yeah, if you want to buy one, I don't know. Of course you can't get this one because I can't show you now, but yeah, it's like it comes like you can't get the EuroPython one now, but like if you look online, there's actually this is called Pew Pew, and also there's another thing similar called PyBatch, that yeah. So you can have fun, and I think, yeah, I just think that we should use Python for other fun stuff, not just, of course, like you can have fun with data, but also you can do, maybe you can have this one and also do some machine learning with it. I think somebody said it could be done, so yeah, why not? So, thank you.
My name is Michael, and this short talk will explain what are Git hooks. So what will you get from this is that you will know what's a Git hook and why you shoot them in Python development and how easy is this really to use them. So 8 months ago, I had a meeting, daily stand-up, with our friends from my current contract, and we had a discussion about using single quotes and double quotes, right? It's a great discussion. So and someone found black, and we decided, okay, you don't discuss with a script. So that was a very good idea. And we decided, okay, we will use it, right, the black, and so how should we use it? And someone proposed that maybe you can use it in your code editor, formatter on every save, right? But not everyone was using VS Code. So someone got an idea to use Git hooks. And we didn't talk about it for the next 6 months, right? So Git hooks, let me click this, are scripts, and basically they execute before or after events such as commit, push, and receive in Git. So you have those scripts in the .git hooks directory, and they are really a script. So on the plus side, they can be anything: Python, Perl, Bash, Haskell, right? They can do anything, send emails, whatever. But you have to write them or Stack Overflow them, and they aren't kept in your repository, right? So, and basically, at that point, I thought that there must be a better way. I was working late. It was pretty late, and I committed my code, pushed it, and waited 10 minutes for the runner to be free on our CI, and it failed on linting. Right? So that was a huge bummer. So I thought, what should I do to not have this issue anymore? Like to not have to wait next 10 minutes. So I thought, okay, so you have to lint before you commit, right? But it's a manual work, and I already failed to do that, right? 10 minutes lost. So I thought that's okay. So maybe 6 months ago, someone said, let's use Git hooks, right? So, okay, I took my courage, all of it, and imagine what I did. I Googled it, right? So I found a website called precommit.com, right? It was so easy. And basically, it's a small framework for managing and maintaining multi-language precommit hooks. You just do pip install precommit, and you create a sample configuration like here. Just one file that you need to commit to your Git repository. This is the simple thing, right? That it removes trading white spaces, removes unnecessary new lines at the end of file, checks YAML files, checks if we aren't committing files that are too big to the repository, right? So you do precommit install. It will install in the .git/hooks directory. And you can run it with precommit run -a, so it will run on all of your files, or it will just leave it for the commits, and it will run before every commit. So as you can see, the fix end of files failed and fixed my file at the same time. So I just need to do another commit, and it's done. So in our Python development with my team, we use PyLlama for linting. We use iSort for sorting imports, so they look nice. And we use black, and we don't discuss about formatting anymore. Thank you. You can find this on my GitHub, this presentation, if you like to have our configuration. Thank you.
Hi everybody, my name is Maarten Breddels and I'm gonna show something about dashboarding with Jupyter notebooks, which is Voila and IPyWidgets. So all this material can be found at this repo. So this is a project that I'm doing together with QuantStack, but it's fully open source. So let's start with a notebook. So I work on BQplot, a visualization library, so of course it's my favorite library. Let's do some histogram of some fake data, and because BQplot is built on top of IPyWidgets, I can change something interactively, the number of bins, but I want to create some kind of dashboard. So I'm going to create a slider and link that to it. Great. Now I'm going to create an extra plot, which is a line chart, and I want to do a selection to filter like the data that I show on top. So now, is it small? Yes, it's really small. Better, yeah. So now I want to share that with someone and not show the code because maybe this person is not technical, or you don't want to show the code because it's a secret code. So there's two ways to do this. Well, there's a package called Voila. So let me push the button. So there's a button in the classical Jupyter Notebook or Jupyter Lab. I need to zoom out a bit. And it will basically render your Jupyter Notebook without the code input. But it's still connected to a kernel. So I can do all of this. It's also a command line util. So let me show that. So you can do Voila, like Jupyter Notebook, and then a notebook, you do Voila, and then a notebook. And now it will spin up a server that doesn't include the Jupyter Notebook. So this is completely safe. Nobody can change your notebook, nobody can see your notebook, but you're still connected to the kernel. Okay, so we want to make this a bit more pretty. And one library that we built on top of IPyWidgets called IPyVuetify, and what it is, it's using modern web technology, a modern web framework, in a library called Vuetify that implements the Google's material design spec, giving you these nice buttons that if you click on them, you get like animations. So they've done all of this work and we wrapped them to get them in the notebook. So we have things like spinners. Let's see, let's do another one. Like, oops. Drop-down menus, etc. And I think the most pretty one is this, where you have a like a really modern looking app almost that you can like configure what it looks like. And this in combination with a template, and I can't show you the template, but it's basically it looks like HTML. So you specify what the template name is. So we made a template that's already pretty good, and we modified the original notebook a bit. And now everything is nicely laid out. So we can change the bin size here. We can change the line style. And this is a notebook running. So this looks like pretty modern. It is actually also responsive. So if I change the size, it should change the placement of where the charts are and should collapse the navigation. Yeah. And now it's like a navigation drawer like this. So it actually works on your mobile phone, on your iPad. And so this is running on this computer. So if you want to share that with someone, you can go to this repo, Maarten Breddels /voila demo. And if you click this binder link, it will spin up a binder and basically show you the same thing, but anyone, like if you can click on this from your phone, and if I had enough time to wait for binder, I could show you that it works. Another way, which is what Martin Renaud did, is to deploy this on Heroku. So basically all the steps to do something like this. Let's see. So it's actually running. So this is somewhere on the cloud and just works. Thank you.
I want to introduce EuroSciPy to you. EuroSciPy is the scientific Python conference. The EuroSciPy this year will be in the beautiful city of Bilbao, which is known, the Basque country is known for the highest density of star restaurants, which are very affordable as well there. It's a beautiful city, it's well connected. There were 2 EuroPythons back then, which were also pretty amazing there. And so let me pitch a little bit more on the food. There's Pinchos, Cider House, social events for networking. Actually, the credit for this slide goes to Mark. Yeah, no, but it's really great. It's a super cool city. We also have the first keynote announced. And you see there's like tons of great speakers, like Martin Bredos. He can tell you much more about Voila. But we really want to push EuroSciPy to be the conference for, of course, scientific Pythons, but also maintainers for scientific packages. So there's a maintainers track this year as well, and this is what we're going to build for the future as well. And there's there's also some great libraries who are already part of this. The call for sponsors is still open, and so you can just reach out if you want to sponsor and support this project. You can find more info, of course, on our website, euroscipy.org. It's, I think, the 18th, so EuroSciPy has been around for a while, and if you want to get more info, is this. And short break, because next I have another conference. So it's PyCon.de. PyCon.de is the German Python conference. So it has happened in all these cities all around Germany. So it's the 8th edition. So it has happened 8 times already. And last year we had a problem where to move the conference. Last year we were down in Karlsruhe in southern Germany. So last year we had a real challenge. Where should we move the conference? So finally, oh no, this is the full animation. I didn't plan for that. Okay, but actually we decided let's go to Berlin, and nice thing happened. We got in touch with PyData Berlin, so we reached out to each other, and actually we decided let's bring these 2 conferences together. So we have a joint conference between PyCon.de, which is more like Python programming and API, whatever, DevOps oriented, and PyData Berlin. It's going to happen in October at Cosmos Berlin. Cosmos Berlin looks like this. It's part it's in Eastern Germany. It's a nice venue here. And let me tell you a little bit more what we have accomplished so far, because actually it's quite thrilling. We have received tons of good feedback, bringing the communities together again, because it's always nice to go into like niches and sub-communities, but many data scientists told me, oh great, I can catch up on my Python and programming skills as well. And then I think it's a really nice message, and so far the collaboration has been like pretty good. So I can prove that with some figures. So the CFP, unfortunately, is closed already, but we received like 450 proposals, which is like players saying, yeah, oh my God. So the schedule will be up in 3 weeks. We have 120 sessions there. So there's 7 tracks, 2 tutorial, 5 talk tracks. We also included a community in the process. So we put up a community voting on all the submissions we received. We had more than 33,000 votes on it. All major sponsored packages are sold out already, so we keep a waiting list for next year if you're interested. We still have diversity packages, so if you want to give your company some presents, please consider diversity packages. We offer free childcare, and 2/3 of the tickets are actually already sold, and we have still 88 days to the conference, so this has been quite amazing. So this for Berlin. Really quick mention, if you're in southern Germany, you can also go to PyData Südwest, which is a meetup. If you don't know where we are, we are over here. PyData Südwest is Mannheim, Karlsruhe, and Heidelberg, so this area. So if you come by, if you travel through, just ping me if you want to give a talk or just visit. It's great. And of course, there's also PyData Frankfurt, which is, you know already, this was our last, one of our recent PyData Frankfurt events. And that's it. So thank you very much.
So yeah, so this talk is called, well, first it was called Things You Didn't Know About Python, but then I found out many things are already known quite well, actually, but at least these are things that I did not know about Python. First, a disclaimer, I borrowed many of those examples from a GitHub repo. It's called What the F Python. So go there. Apart from the fact that there's many like surprising things in Python and it's really peculiar, it really helps you, at least it helped me to understand some of the internals of Python. So, so apart from the fact that it's super funny, some of these things really helps you to get a better understanding of Python in general. So let's get going. Before making this talk, I did not even know you can make slides in Jupyter Notebook, and it's super simple and super easy, so do it. Python was conceived in Amsterdam, a few kilometers from the company I work for, GoData Driven. So it was like a hobby project of Guido van Rossum in 1989. He says like, my office would be closed, but I had a home computer and I had not much else on my hands. So it was quite a good way to spend your Christmas holiday, I think, and the rest is history. The language name is a tribute to Monty Python. I expect many people that are from at least the UK that they know this, because Monty Python is like a British comedy show. But this one I really did not know. Spam and eggs, that's used in like the Python documentation. It comes from a very famous Python sketch, Monty Python sketch, I have to say. Spam as in junk mail also originates from this sketch, and the sketch is about customers that try to order breakfast from a menu that includes spam in almost every dish. Much to the consternation of one of the customers. Yeah, we don't have time to watch it. Check it out on YouTube. So some more technical stuff. The implementation of the OR statement. Can you even read this, or is it, yeah? Is it too small? Maybe, wait. Yeah, is it, can I zoom in, or? Wait. Yeah, it was okay. Yeah, okay, so it's like this. So it just says basically if you say like A or B, then it says if A, and otherwise if it's true you return A, and otherwise you return B. So, wow, yes. So instead, if you give like none as a default argument, instead of checking if X is none and otherwise assigning immutable, you can also do this. It was quite a surprise to me. I don't know if it's good practice. Maybe there's someone around that can tell me it is or it is not. I think it's less explicit, but at least it's interesting to at least know how this OR statement works. Python has a for else statement. I did not know. So it basically also only hits the else statements if you iterate through the full iterator of the for loop, basically. Yeah, there's one example that you can use it in some like search thing, but I never used it, probably never will. Nobody ever got fired for choosing Python. It's also a good one. If you say like import this, it returns the Zen of Python. I think many people know this. It's like, well, beautiful is better than ugly and the whole shebang. This one is quite peculiar. So if you assign 256 to A and B, then they're like, they're assigned to the same, like, let's say, memory slot. But here it's not for 257. This is strange. Well, it turns out all integers between -5 and 256 are pre-initialized and referenced when used. So this is, I think, for performance things. You are doing the time, right? Because otherwise I go on for like half an hour. Is not is a single binary operator. So it's not that you have is and not, and you can combine them, but is not is a single binary operator. Python has a try, except, else, finally statement. Also never used it, probably also never will, but it has applications. This one is very nice. So Python uses indentation instead of braces to structure its programs into scripts into blocks. So we all know that. But if you really want braces, you can use braces. This is just a joke. It doesn't work. Okay, using mutable object. Yeah, many of you are thinking like, what the? Using mutable object as a function default is a bad idea. So this is some people, I think I made this mistake in the beginning without even realizing, and this is like, so never use, for example, a list as a default argument. So you have to say like X is none, and then if none is, for example, passed, then you assign an empty list to it. In a for loop in every iteration, the item provided by the iterator is assigned to the target variable. So if you have you iterate over some string, and this is actually very strange, but this is just as an illustration. And you can, like, in this for loop, you can actually assign to this dictionary. So it's actually assigned when you loop over it. In Python, you can chain comparisons. So you can, if you have like A smaller than B and B smaller than C, you can do it like this. You can also do this. I found it very surprising. So you can also chain like equality, let's say, operators. So here I would say like, okay, X is 5 is assigned to X. So first it's like, to me it would say like, okay, true is larger than 4, but this is not the case. It's actually chained as one like operation. In Python 2, true and false were built-in variables and not constants. Okay, this is okay. It goes on until like 50 or so. Good.
Okay, hello. So today we had a wonderful couple hours of very, very intense hacking, and I'm going to just give a few minutes saying what we actually did together in the Mortimer room this afternoon. So we ran a democracy hackathon, and just to keep things simple, we had a number of challenges, a huge number of challenges, such as let's solve democracy. How do we do that? Well, lots of the data that you need to research into the world of politics or the world of sort of candidate elections and voting is in PDFs. And this is our greatest data source, and it almost never gets analyzed because it needs to be manually extracted. So if anybody, and we did this last year, if anybody could do that, that would be great. It would be a real game changer in this industry. Voter engagement, fake news, misinformation, public sentiment. We had a machine learning competition, because who doesn't love a machine learning competition? And we also had a prize category for open data for democracy initiatives. So number one, what do we manage to do? This was what we were trying to tackle last year, and literally nothing has changed in a year's time in this entire space of there is data. There is really good data in PDFs, but it will stay there forevermore until we figure out a better way of getting it out. And the state of the art is still this. It's not really good enough for automated extraction yet. This time we switched things up and we looked at election candidate data, and we realized there's no standards around any of this. It is just put in there by humans for human consumption, and it reduces very quickly down to an incredibly, almost intractable NLP problem. So that was a couple of people spent a good 2.5 hours on this today, and that's roughly what they concluded. Some other people looked at voter engagement. Again, they were looking at building tools for making it easier to actually register to vote, because at the moment it's a very almost manual process of sending things off. So how can we digitize that entire thing? The hardest bit is actually just the signature, getting that through to your local office, getting that verified. So some really exciting initiatives built by another team on this front. Number 3, fake news, one of the biggest new phrases of the last few years. And a few people were looking into how language was used online, especially on Twitter. This turned out to be, well, it's never easy to actually get lots of data off Twitter to start doing some NLP analysis. I think one team was literally trying to build a very meaningful, impactful startup by doing some sort of topological classification of Twitter graphs. Again, not the easiest thing to do in a couple hours. But they did something. They proved perhaps that tweets associated with Leave supporters have a greater strength of opinion. Take of that what you will. Number 4, the machine learning competition. So the challenge that we posed people this year was, can you predict turnout in an election? Because it's very hard to actually ask people to change their opinions on what they believe. It's much easier to just get them to persuade them that their vote is worth actually going a few hundred meters down to a polling station. It's going to be worth it. So if we can figure out how to predict turnout, we can figure out what the factors are that impact turnout. And so we got our contestants started with a notebook ready to go and a model ready to go, which had a 4% average error per party per seat. And a team after 2.5 hours managed to reduce that average error from 4% down to 0.027%, I believe, with a light GBM model with some census demographic data merged in and some very useful sort of domain knowledge. In fact, their quote was, we realized that domain knowledge gave us the most impact versus just fancier models. So congratulations to that team and their new winnings of House of Commons branded coffee for coming along today. Thank you to all of them. We have more, though. We also had a task around open data for democracy, and this was one of the hardest things that I've ever come across, is just the amount of time it takes to get the data from its various data sets and data sources, or even getting it off archive pages that some other extremely nice person has put up, because the Electoral Commission does take data set sources down. So how do we get this data? How do we make it accessible? How do we make it publicly available for people like us to just come and use, so it's even possible for a team to come and solve that machine learning competition in just 2 hours? Because to get to that point was months of my time just getting the data sets in the right shape so that it could be matched up with all the right identifiers. So I have just released this week a package called Maven, which is aiming to bundle all of the work that I've been doing over the last couple of years into an easily installable Python package that does all of the data access, retrieval, processing, cleaning on device, so as to not tread on any toes around licensing issues. And also so you can see what transformations I've applied and change it if you think they're not good. And so we also had some people contributing back to Maven, doing their first ever pull requests, and also getting involved. So if you want to see what that looks like, it's literally, there are identifiers for every data set we've ever scraped and processed, and you just do a .get, throw in the identifier, and it gives you both the raw and the processed data side by side in your local repo. So this is available on PyPI. Just do pip install Maven or come talk to me later if you want to find out more. Otherwise, thank you very much. This is a very, very hard field to work in, but very challenging and rewarding. Thank you.
Good afternoon, good evening. My name's Jason, and I want to tell you about a project I did at university. And I used IPython widgets, and I want to tell you a little bit about those, and also a little bit about having fun with your model and playing with it a little bit, and making it into a little bit of a game. So the context is I had this university project for my visualization course. The data set was using the VAST challenge data set from 2018, I think. I don't know if anyone's worked with that before. It's a visualization community. And what they have is a series of challenges, but the one I looked at was we've got just over 2,000 labeled bird tweets. Okay, they're labeled into, I think it was 19 different bird species. And what you're given is a test sample. You're given 15 audio samples that you have to classify. So this looks like, to you, to me, a classic machine learning exercise, right? And a lot of people who entered the competition, they did the same thing. Okay, so I got very excited by this. I thought, oh, great, I'm going to have some fun with this. I'm going to go deep learning. I'm going to really enjoy the visualization side. I'm going to build this amazing front end for my professor to see, because I can't just give her code. She's not interested in that. This is a visualization task. Right? And I looked at what everyone else did, and what they did was amazing. I don't know how long they took, but I had a hard deadline. I had, a few weeks to do this, and best laid plans of mice and men, it all kind of fell apart. And what I ended up doing, I wanted to build this aim here, determine the likelihood of each of the clips, the classification model, visualize. What I ended up stripping it back to was I did a lot of exploratory data analysis in the notebook. I produced loads of nice visualizations there. And I ended up taking that notebook and making that into the final product. So where I was going to hopefully use something like Plotly or Dash, I ended up using the notebook. And that was a really good and very quick way to do it. And what I did was I took the notebook and I just stuck a few IPython widgets in there, and that was very useful to me. So if we've got time, I'll just try and have a look at that with you. So up here, so we've got, I feel like it's like I'm showing you my naked body here, but this is the actual script. So I never actually prepared this for anyone to actually look at, including my professor. But of course, as you've seen a few things today, yeah, we can hide all that. So there's a notebook. That was what I was working with. I tidied it up a little bit. But at the end of the day, we're just left with this. And I don't think you'll be able to hear these, but here we can start listening to some of the clips. Here we have some spectrograms to understand the audio, the bird sound visually. What's here is what's called a rose-crested blue pipit. And this is what it looks like as a spectrogram. This is what it looks like. We also have the location of where all the samples, where all those audio clips were taken. And this is what it looks like in the nature reserve. This is the location of where that audio sample was taken. And the blue is other samples of rose-crested blue pipits. And what we can do here with the user is we can actually train the user on how to distinguish a pipit song, a pipit call, and then something which is not a pipit. And I wish I could play these for you now, and it would be interesting to see the human learning side of machine learning. And then at the end, we can load a random sample of those 2,000. And what it'll do is it'll load up the visualization, the audio clip, and the location. So this could be, and what's missing here, this little section here, this is where my machine learning model was going to give its predictions. So I wanted this to be kind of like an augmented approach. So we've got some classic visualization plus our machine learning. So we get to see all the information. And then at the end here, this is what I mean by you can play a game with your machine learning model. We got the classifications. Is this a pipit or not pipit? Now, I've done this a few times. I think it's not a pipit. Look at the location. Look at this. This is what a pipit song looks like. This is what a pipit call looks like. So I don't think that looks like any of them, so I'd say not pipit. And, you know, correct. It was some other kind of bird. And then I can basically just go through this loop again. And what I did is I gave this to a test sample of people. And I asked them to work through this, to learn, and they all learned how to classify. And then I could leave them with this, and they could try and classify some. So look, this one looks very much like the pipit. That pattern, I know you can't see it very well, but this pattern looks very familiar. And look at the location. So I'm going to say that's a pipit. Yeah, look, no surprise, I'm getting this right every time. But I've classified probably about 50 of these things now. But the interesting thing is, for me, I did this with human people, and although the classifier, which I did eventually get working after the deadline, worked with 2,000 samples, it turns out that humans can do this job listening to about 10 samples, and they'll be about like 85% accurate. So don't give up on the humans yet. Okay? Thank you.